Hey guys, I hope your week is going well. I just wanted to go through this again. This is like take 20 of this video, and then now I'm redoing it because I made some changes to the worksheet. I know I went over this with you guys last Wednesday in class, and then again Thursday, but I made some changes between Wednesday and Thursday, and I just kind of wanted this video to reflect those changes. So just as a reminder, you guys will be working in this simulation. You guys can access it on Amplify 2.3 or 2.4. It doesn't really matter. It's the same simulation. But you guys will be working on this 3 population where you guys can see the energy storage molecules. Remember, in order for an organism to be able to reproduce, it needs to have plenty of energy, okay, and energy storage molecules. So you guys will click on that. You guys can zoom in a little bit, and then you're gonna let it run for 20 time units and pause it. Okay, I just want to show you guys really quick your food web. So this should be for part 1, and that's really all you guys need to know for part 1 other than instructions. If you guys click that little button, you guys can see this food web overlay. So in that, you guys can see that the green leaves give their energy to the wee bugs because the wee bugs eat the green leaves, and the wee bugs give their energy to the fur bills because the fur bills eat the wee bugs. You guys can also see their energy storage molecules in the orange, and then the population numbers are the big ones. So the big thing that you guys are examining in this whole assignment is what happens, what direct change would we have if we changed one of these populations in this food web? How would it change the others? So you guys could see a direct change, and that's all you're going to be studying today. So if we change like the number of fur bills, it will directly affect the wee bugs, okay? If you change the number of fur bills, you guys are going to indirectly change the number of green leaves, but we're just going to study on those direct ones, the organisms that are right next to each other in the food web. So in your example, we're going to be talking about, and this isn't the same thing that you guys are talking about in part 2. This is just an example I'm showing you. So in this example, we're going to change drastically the number of fur bills and observe what happens with our wee bugs. So what you guys will need to do is, again, run it for 20 time units so you guys have some data to collect beforehand. And then you'll click on this little right arrow over here. You'll change your fur bills. Remember, if we want to really see an observable change in our wee bugs, we really have to make a big change in our fur bills. So keep that in mind when you guys are changing any of these examples today in class. I'm going to max out my fur bills to 100. Okay, and then I'm going to lock that population. So if you click the little lock on the right side of that, that just means that we're going to keep our fur bill population at 100. It doesn't mean that there's no fur bills being born or dying. It just means that the number of deaths is equal to the number of births, roughly. Okay. The other questions that I want to go over with you guys is the dependent and independent variables. So the independent variables is kind of your manipulated variable, or the thing that you're directly changing. So I just directly changed the fur bill population to 100. Okay, so that's my independent variable. What we're going to observe then is what happens to the wee bugs. So that's going to be my dependent variable. Okay, so again, your independent is what you guys change, and your dependent variable is what you guys are observing as far as a population size. So that would be our wee bugs. Okay, so then after that, you guys have made those changes and figured out your independent and dependent variable. You guys can go ahead and hit play. It doesn't matter if you guys have that overlay open or not. You'll play it for another 20 time units. And then you guys are going to hit pause and examine your data. So this is where you guys will see the big change that I made to this worksheet. Before I had you guys recording the number of deaths and the number of births, I just want you guys to record population size. So we're going to ignore deaths and births. By now you guys know that if you have more births than deaths, your population is going to increase. If you guys have more deaths than births, your population will decrease. And if they're about the same, of course, your population will stay the same. So then you guys will click Analyze, and you guys will see this graph. Okay, so this is where I let it run for 20 seconds and then paused it. I changed my population of fur bills to 100 and then kept them at 100. So this is kind of the first 20 time units, the last 20 time units, but the data tells you guys, let me open up my Word here, on part 2, it asks you guys to find before the change and 20 time units after the change. So we're again just going to look at the population size and the change in population. So if I'm doing this example with the fur bills, okay, before the change I would take this dark blue line here and I would drag it before I changed the fur bills to 100. So about right there is about where I changed it. So you can see I had only 25 fur bills. And then I'm going to come over here and look at my wee bug population and say, all right, before I changed it, my wee bug population was 104, and they were slightly decreasing. So I would record 104 here, next to before the change, 104 wee bugs. The change was a -6. Okay, if I go back to that, I'm gonna go after, so 20 time units after, so I'm gonna drag it clear to the end where I paused it after the 40 time units. And I'm gonna observe again. So my wee bug population was 98 and my change was -7. So that's not the best example, but you guys can see that obviously the population decreased a little bit more. So again, I would go into my worksheet, record 98, and -7. You guys might want to run these twice just to kind of see if there's any difference in your data. Okay, so in part 2, you guys will be looking at changing the number of green leaves and seeing what happens to the wee bug. So you'll just follow directions on that. Again, you'll run it for 28 time units, pause it, change your green leaf number accordingly, whatever it tells you to do, and then observe what happens to your wee bugs and record that data I just showed you. In part 3, you guys are looking at question number 11 says, what changes would decrease the number of deaths? So if we're decreasing the number of deaths, it means less organisms are dying, so the population is increasing. So what changes would decrease the number of deaths in the wee bug? Well, the wee bug population would be increasing. So there's 2 here that you guys will be changing to increase your guys' wee bug population. So you guys will test both of those a couple times and record your guys' data. Just the same, you're just looking at population size and that change. Remember, if your guys' change in population is growing, it should be a positive number, and if your population is decreasing, this should be a negative number. So other than that, I think it's pretty self-explanatory. I think I've already gone over this plenty in class. So you guys should get the hint by now. I hope this video helps you guys out. I hope you guys are having a great week, and I'm sure I am just missing you guys and dying to come back from Mexico. Work hard today and the rest of this week, and I will see you guys when you get back.